In lesson 4.5, we are going to be talking about triangle congruence. In the last lesson, we proved that two triangles were congruent by definition if all three pairs of sides were congruent and all three pairs of angles were congruent. Today, we're going to talk about the fact that it's possible to prove two triangles congruent using fewer pairs. In other words, today we're going to talk about some shortcuts. The first shortcut I'm going to introduce to you today is called the side-side-side shortcut, and they will typically abbreviate that as SSS. What the side-side-side shortcut says is that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are going to be congruent. So as you take a look at the diagram showing the two triangles ABC and DEF, I see I have sides of 4, 6, and 7 centimeters, and over here 4, 6, and 7 centimeters. Well, that information is enough for me to prove my triangle's congruent. Even though I don't know anything about my angle pairs, I do know that I have 3 sets of congruent sides. Therefore, it is showing me side-side-side shortcut. Now, if I wanted to write my congruency statement, I have to make sure that I have my letters in corresponding order. And in this case, it's a little bit tricky. Triangle ABC here would correspond with triangle FDE. So the second one doesn't necessarily go in alphabetical order, but in corresponding order, it would match FDE. When we go to write a proof for congruent triangles, now that we can use shortcuts, our proofs are actually going to become much shorter. We aren't going to have as many steps. So as you take a look at the proof underneath, we are trying to prove that triangle ABD is congruent to triangle CBD. We know that we're always going to start with our givens, so I'm going to go ahead and say AB congruent to CB, AD congruent to CD. And we also want to double check that that is marked on our picture. AB congruent to CB would be these tick marks right here. AD congruent to CD are the double tick marks. That's it for my given information, but as I take a look at my diagram, I do see here these triangles have a shared side. I can go ahead and mark that shared side congruent. But if I make a marking in my diagram, I need to come over here and make a statement. I'm going to say BD must be congruent to BD. Well, something congruent to itself, we said last time, would be showing the reflexive property. Now, if you take a look at my diagram, my two triangles are showing me the side-side-side shortcut. So I can go ahead and say, well, triangle ABD must be congruent to triangle CBD, not by definition of congruent triangles, but by the side-side-side postulate. Underneath that, I'm given a second proof. Much the same, I'm trying to prove that I have congruent triangles. I know that I'm going to go ahead and start with my given information. And because this time we have quite a bit, I'm just going to go ahead and take this and move it down here with an arrow, saying that we're going to start with that given information. As we read through it, it says that HF is congruent to HJ, those tick marks there. FG is congruent to JK, and that H is the midpoint of segment GK. So here, point H, my midpoint. Well, I know if my segment has a midpoint, it splits it into two equal parts. So I can go ahead and mark those segments congruent. if I make that marking of those segments congruent, I need to make that statement in my proof. So I need to say or state that GH is going to be congruent to KH. How do I know that? Well, that will be because of my midpoint. And once again, I have now shown my two triangles congruent by the side, side, side shortcut. I don't necessarily know the specific angle measures, but because I used my shortcut, I do know that they would be, the corresponding angles would be congruent. If you take a look at the top, I have my triangle ABC. And if I look at my triangle ABC, I have angle B highlighted. Well, looking at segment AB and segment BC, angle B is in between those two segments. So they are going to call angle B or state that angle B is an included angle that is formed by the two adjacent sides of our polygon. Okay? When I think of the word included, I kind of think of the word in between, or the phrase in between. It leads me to my second shortcut. A second shortcut that we can use is called the side angle side shortcut, abbreviated as SAS. But here the order is important, so note that the angle is in between my two sides. It reads that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles must be congruent. So if you take a moment to look at my two triangles here, they are showing me the SAS, or the side angle side shortcut. I have two sides and the angle in between. Side, angle, side, side, angle, side. That is enough information to prove those triangles congruent. Now, in some of your questions, they're going to ask you if you have enough information to prove triangles congruent. For example, in number 1, when they ask you, can you prove triangle RED congruent to triangle CAT? Well, taking a look at my triangles here, I can see that I have side, angle, side. The angle is included between my two sides. However, when I look over here, I see I have side, side, angle. These two things are different, and side, side, angle is not one of my shortcuts. And so here I'm going to have to say no. I cannot say my two triangles are congruent. This triangle does not have the included side, the included angle, excuse me. In diagram number 2, we're wondering about triangle AEB and triangle DBC. I do see that I have two sides marked congruent. Now sometimes kids will say, I want to mark that third side. I want to mark AB congruent to CD. I'll tell you though, we can't mark anything just because it looks the same. We have to be able to justify it. And so I can't mark the third side the same. I will say, though, there are some vertical angles in that diagram. So I would be able to mark angle ABE and angle CBD congruent because they are vertical angles. But again, when I look at the markings of my triangles, this triangle shows me side, side, angle. And this triangle shows me side, angle, side. So again, because these do not match, I'm going to have to say no. I cannot prove them congruent. I don't have enough information. They could be, but at this point I can't determine it. In diagram number 3, when I look at my two triangles, I have one set of sides marked congruent and I have one set of angles. Again, I cannot mark anything congruent just because it looks like it would match. But in this case, I can justify marking that side RS. RS would be a shared side, and so that would be congruent. Here, both of these triangles do show side, angle, side, side, angle, side. So I'm going to say yes, I can say these are congruent using the SAS shortcut. In example B, they're asking us to give some missing information. They want to know what other information we would need to prove my triangle ABC congruent to triangle CDA using the SAS shortcut. When I look over here, I do see I have a triangle side lengths of 6, 7, 8. My other triangle only has side lengths of 6 and 7. Therefore, if I were looking to prove my triangles congruent, I would need to find that missing angle. I need to know what angle would be my included angle. Well, here, between sides 6 and 7, that would have to be this angle right in here, the included angle. Because this is between side 6 and side 7, over here on this triangle, I have to match. Between side 6 and between side 7, the included angle would have to be here. That's the information I need to use SAS shortcut. If I needed to write that in words, I would have to name them with 3 letters. I could say that angle BAC congruent to angle DCA. In question number 2, I see they're asking me to prove triangles congruent by SAS. Now in this type of diagram, I see many triangles. And so I need to make sure that I go over to my statement and see which ones they are talking about. They want triangle ADC and triangle BCD. A lot of times I will take a diagram like this and I will use a highlighter to outline my triangles. Triangle ADC would be this triangle right in there. And triangle BCD this triangle right there. So I have my yellow triangle and I have my green triangle. Well, another strategy for these is to maybe pull these triangles apart. And so I could draw them separately. Again, kind of pulling them apart or separating them. I do recommend that you label your vertices. The sides marked congruent here are my shorter sides. But in this diagram, these triangles do have a shared side. Do you see that overlap? Right here at the bottom, my shared side. So I can go ahead and mark that down here as well. So I do have 2 sides marked congruent. I want to use SAS, meaning I know I'm looking for an angle. Which angle would I need to know in order to prove my triangles congruent? Well, we would need the included angle in between my sides, and it may actually be easier to see in the separated triangles. It would have to be this angle here and here. Now, I can't just say angle D or angle C because in these triangles, it's unclear as to which angle that would be. And so I'm actually going to name them using 3 letters. I would need to know angle ADC congruent to angle BCD. I also have posted on our homework webpage some other example videos working through some proofs. I recommend that you check those out, and if you have further questions, please come in and see me.